I'm Sasha. I'm going to tell you, thank you for sticking with me through that, I appreciate it. Let's start out, let me tell you a data story, and it's a data horror story, actually. This happened to a client of mine. They were an e-commerce company that had a very interesting data set. They hired us to take a look at it. And the VP we were working with had a great idea. He was like, hey, we're an e-commerce company. It's November. The holidays are coming up. Let's do a story that compares the shopping season last year to the shopping season this year and put out a piece. The press will love it. We'll get all sorts of new customers. And we were like, that sounds great. And then we looked at their data set, and they had a problem that their engineers knew about and fixed in April. But their data before April was not really usable. So we had to go to this VP and say, no, you can't do this great press story because you lost the first 8 months of your company's data. It's unusable. And he was like, so this is a data horror story. Don't let this happen to you. That's what this whole talk today is about. It's about preventing horrible data problems down the road for yourself. And this talk is really for people who like starting things, people who like are starting companies or products or even adding features to existing products, or just don't even have a data science team yet and haven't done this sort of thing. And you might be like hard to sleep at night because you don't know if your data set has these sorts of problems. And these sorts of horror stories keep you up. And so, hi, I'm Sasha. I also like starting things. Two things that I've been either started or early at are, you may have heard of our Code Academy. I was an early hire there back when they had one lesson on the site. I also started a group called Women Who Code that has 15,000 women developers across the world. So I really like being there in that early stage of things when it's super chaotic and your to-do list is so long you don't know where to start. You just have to put it in order to start at the top. And so we've worked... now I work and I'm helping start Polynumeral, which is an applied data strategy consultancy here in New York. And one thing we do is we work with a lot of different sorts of organizations. We work with tiny nonprofits, we work with startups, we work with big established companies, we work with NGOs halfway across the world. And we help them be more strategic with their data and do new and interesting things. And so we've seen a lot of different data sets and a lot of different constraints. And we've worked with a lot of great, super solid engineering teams who are pushing out super interesting products and doing their best on this logging thing, and still made mistakes that bit them later. And we've actually had a few of these mistakes slip by us when we audited their data. So we've been like iterating each time we do this to make sure we catch more and more of these mistakes. And I want to share the last year of this with you guys today with some more stories that unfortunately I have to fuzz a little bit to protect our clients. So I am going to be a little vague in some of these stories. So today, the talk is going to cover, is your data set complete? Is it correct? And is it connectable? And these are three things that you can go off and check. Take a few days to check now and put your mind at ease. The rest of the talk is going to be expand on these three things. But before we talk about that, why bother? Why bother doing this? How can you justify to yourself and your long to-do list and your boss and all your stakeholders why it makes sense to do these things now? I mean, aren't data scientists wizards? Well, yes, but no, algorithms are useless if you don't have any data. No matter how smart a data scientist you hire later, they can't do anything if they don't have a good data set to work with. If the data is missing or it's wrong and you can't trust it, like it's very hard for them to do good work. So if you get your ducks in a row now, you're setting yourself up to do really interesting things down the road. So let's look at the... Another exercise that I'd like you all to do right now is think of a project or a company, like pick one in your life that you're thinking about applying this stuff to. And think about what is critical. So what are your business needs for this project? And I don't mean business literally. It doesn't have to be a company or something that even has money associated with it. And if you're at a loss as a project to think about, pick a website you spend a lot of time on, like Reddit or Hacker News or the New York Times or whatever. Business needs really mean what moves the needle? What actually makes a difference? What gets you more users? What gets you more revenue? What cuts down on your bounce rate? What gets your app more downloads? Whatever that success metric is to you, take a second right now and think about what actually would move the needle for you. What matters? And I'm going to need you to keep that in mind for the next part. Okay. By the way, this is really hard, and if you're sort of struggling with this, I know some great data scientists you can call and ask for help. I know I'm being somewhat facetious, but my coworker literally wrote a book on this. It came out by O'Reilly in February. It's a great book. It's a very quick read. I highly recommend it, especially if you're just getting started in data science. So keep this question in mind. What is critical? What matters? Okay. And let's go through the first of these three things. Is your data set complete? So what this really means is Are business critical fields okay? This is one of a few things you can check. So let me tell you another story. We had one client that asked an interesting question. They have a very popular and beloved widget that's all over the internet, and they refer a lot of traffic to all these various sites. They don't refer as much as Twitter and Facebook and those sorts of giants, but they had a hunch that their traffic was more engaged, that it was better quality traffic. They'd be more likely to comment and stick around longer and click through pages and all these sorts of things. So the quality of the traffic they suspected was higher, and they asked us to check that for them. They weren't currently logging refers, so we didn't actually know where people were coming from. So we had them log a URL that looked something like this. And so we could see whether the refer was our client or someone else. However, they truncated that piece of the URL. So we didn't know where they came from. So they were tracking this URL, and everything was great, except the one thing we really needed to do the analysis was gone. Luckily, we caught this very quickly because we knew it was so critical for our work, and we got them to fix it. But make sure the business critical fields that you really need to do the work that matters are actually there. And those are the first things you should start with. One other thing you can do is check to see the overall volume is right. And you guys are not going to believe me that you need to do this, but you really do. For example, check against other pieces of knowledge you have. Like, let's say Google Analytics. Let's say you're running an awesome project and your Google Analytics says you have 500,000 people coming to your site per month. Congratulations, first of all, that's awesome. But what if your logs only have 5,000 unique users per month in them? You're missing 99% of your data. This actually happened to one of our clients. Like, this is real. I'm not making this. I'm fudging the numbers a little bit to make the math easier, but like, they were literally missing 99% of their unique users. So check this. I know you don't think you have to, but just make sure the volume of people you see in your logs is actually lining up with what you expect through other sources of information. One other sort of mind shift you might have to make if you're mostly a software engineer is to not just log errors. If you're getting a product up and running, you want to log the errors that are happening in your software so you can go track them down and fix them, right? But logging all sorts of interesting and useful main functions that people do on your site can actually give you a lot of insight. And of course, the corollary of this is take extra good care of this data and keep it safe, because people are really trusting you with that. And so if you're going to log a lot of actions on the site, that gives away a lot of information about people, so take good care of it. But here's another example of this. One of our clients is a large media company that has articles and email newsletters and audio content and video content and a place where you can donate, right, a transactional one. And they wanted to see if they could predict who would donate more based on their activity on the site, which makes sense, right? If you're more interested and you come back every day and read their stuff like 8 hours a day, you might be more likely to donate than someone who comes once a month and then leaves. But they're only logging 2 of these things. They're only logging the donations and the newsletter stuff. And the only reason they were logging the newsletter stuff is because MailChimp has like pretty robust data and does this stuff for you. So that is a problem for our analysis. So we had them track these sorts of things so we could see who is viewing what and get a better sense of their activity over time. And so make sure that you are not just logging errors, but you are logging important and meaningful activities that people do on your site. And if you're thinking this sounds like a lot to log, it is, but storage is so cheap right now. It's so cheap and it just keeps getting cheaper. I bought a 1 terabyte hard drive on Amazon for $50 and it's about this big. So storage just keeps getting cheaper. If you price it out, you'll find that it's really not that much. So, is your data set complete? Make sure to check those things. Now let's talk about if it is correct. This is another place where you can check your data set against existing knowledge. So, for example, one of our clients had a product that's like fairly gender neutral, but probably skews a little bit male. So they were like, maybe we have 50 to 60% male users. And this was relevant to the project that we were doing. And so let's check it out. You guys can come along with us in a case study where we check to see that this knowledge, existing knowledge about their users, is accurate. And so one of my favorite tools for doing this is actually the terminal. In order to do more heavy-duty analysis, you need something like Hadoop or Spark or whatever. But to just see if the data lines up with what you expect and to do a quick audit of it, the terminal is pretty much the best tool you can use. It's quick. You can use all sorts of really robust tools. You can make your own tools and package them up. We'll talk about that in a minute. You can chain things together so you can really quickly slice and dice the data. It's really awesome. This is a really important skill that I use all the time. And there's a book that just came out about it called Data Science at the Command Line. I highly recommend it. It's great. I took a look through it. It uses a lot of the tips and tricks that we at Polynumeral use every day. And if there is one thing you take away from this talk, if you are asleep through the rest of it, wake up and write this down. CSV Kit is the #1 tool I use all the time. It's amazing. It just keeps getting better. And it's Python. I almost made that blank, but then I decided not that would be too much. So CSV Kit, it's written in Python. The code is all up on GitHub. It's pretty nice and clean and concise. And it has a ton of different pieces in it. There's into CSV, which lets you connect Excel files to CSV. You can write SQL queries that query your CSV, because sometimes you just really got a SQL. There's CSV JSON, CSV look, CSV grep. We're going to use CSV cut right now, but there's a ton more. This is like 1/3 of what they have in CSV Kit. So let's look at an example. And I totally made these numbers up, obviously. And so I'm assuming you're all familiar with the bash prompt, the $ where you type commands after it. Cat just prints out logs.csv here, and so we can see logs.csv here. Let's see if I can get my, if you won't click for me, let's see if you can laser point. So we've got a header row here where you've got the user ID, the name of the person, their gender that we've logged, and notice we have a blank one here, we're not sure about that one, and then a join date. Okay, so right now we're printing it to the screen, but we can also pass it into a new command. So let's pass, with the pipe here, let's pass the output of printing the logs into CSV cut -n, and that prints out the names of the columns. So you saw here, there's UID, name, gender, join date. It prints them out here and numbers them for us. And so number 3 is the one we're really interested in, gender. So let's change our -n option to a -C3. So give me the 3rd column, C is for column. And so it just prints out all the values. And since my CSV is only 4 lines long, I have 4 things here. If you had a long CSV, you would have a lot of things. And so we've got gender, which is again just that string that's in the header row, and then MF and empty string. And I put the quotes there so that you can see it on the screen. Now, let's do something else with it. So we've got printed our logs, we've taken the 3rd column. Now let's pass it into sort, which basically puts them in alphabetical order. So we're going to group all the M's together, all the F's together, all the empty strings together, and that one gender string goes wherever it goes. And then unique them. So you're compressing all the M's together, compressing all the F's together, and then counting how many of them there are. That's what the -C option does. So this is our output. We've got about 600 women, about 6,000 men, 1 gender header entry, and a bunch that are blank for some reason. So what do you guys think? Would you trust this field? No, this is about 90% male. Remember what we thought it was supposed to be? Like 55, 60 maybe, right? So there's something wrong with this field, and it turns out there was a long time in their product's history when they didn't know the gender of the user, and so they just wrote down M. And they caught this a little bit later and fixed it, but there's a long period of time where you just cannot trust this data, and the problem is that all of the users they acquired during that time don't have this field. It's not reliable, it's not accurate. So this is problematic. So check these sorts of things. Just make sure you're right. Just check them. Just check them now, even if you're totally positive. And by the way, the one really cool thing about this command line approach is that you can actually make your own. You can make your own command line interface modules. The book I mentioned before, and I'll send you guys a link to it afterwards. The book has a very detailed chapter. You can take Python stuff, you can take R stuff, and you can like package it up and use it in this chained command line fashion to quickly look through your data. So it's super, super handy. So you have checked that your data is correct. What next? Let's take a look and see if it's connectable. So, is your data set connectable? What I mean by this is, can you actually join it? And just in case people don't know what a join is, I'm just going to go over it very quickly. Let's say you have some census income data. So you have over here, you have zip codes, and then you have the median income in that zip code. And again, I totally made up these numbers. Please don't quote me on any of these. You could also have a list of 311 calls, and for those of you who are from out of town, 311 is the way you report problems in your area. If you have no heat, if you have rats, which is like a constant thing in New York, noise complaints. Looking through these codes is actually very funny. I highly recommend it. there are some entries in this file that you can get online where I just want to be on that call and like hear what the person answering the call heard, because what they wrote down makes no sense. So anyway, check this out. It's a very funny data set. So with this data set, you can answer questions like, what's the richest zip code? With this one, you can answer questions like, where are the most complaints? But if you were to combine them together, you could answer questions like, do rich people complain more than poor people, or something like that. You could combine these two data sets. Or do poor people have more things to complain about than rich people, which I think is a more plausible explanation. And so what we want to do is we want to smush these two tables together, and we don't just want to glue them together, we want to do it intelligently. So we want to find the places where they line up. So we have 11201 here and 11201 there, and so we want to find them all and like put them all in the same line together. And so that's called a join, and our join table will look something like this. So we've got that one zip code we're interested in here, we pulled its median income, and we pulled the complaints that the person was complaining about. And so we have a long table of all these together. This allows you to ask much more interesting questions. And to be totally honest, if you don't do this in your data sets, in your work, you're going to have a lot of doors are going to be closed to you. There's a lot of super interesting work that you just can't do. And so how can you find out if your data can join? Actually do it. Like, do the join. Like, take a big enough sample that you'll get a meaningful number of joined things out of it, and do it. I've done this before, expecting it to give me like 400 million like joined entries, and it gave me 0 or 10. 10 was the weird one. Actually do this join and check to make sure that it works. Like, spending maybe an hour doing it would really save you a lot of time. And then check that join table against your existing knowledge, just like we talked about before. One way to get a quick look at your existing knowledge and what's in your data set is histograms. And I have a very handy little tool for you that will give you a histogram of your data very quickly. It is called Data Hacks. It's put out by Bitly, it's on GitHub, and I'll put out a link to this later too. And what you do is you basically output you slice and dice your data with CSV kit like before, and then you pipe it into a bunch of these functions. And there are 5 or 6 in Data Hacks, and I'm going to show you histogram.py, which is the one I use most. And so here's an example. I just took this straight from their GitHub page. You print out your data file into histogram.py, and then it does a bunch of stats up here, which is really handy. So it tells you, first of all, how many things there are, which you probably already know, but it tells you the max and the min. So you might find some like really wacky numbers in there that you weren't expecting to see. This might tell you more, the mean, the variance, standard deviation, and then it prints out an actual histogram. It generates it for you. So what this is saying is that there is one thing with a value between 1 and 1.9. There are 5 things with a value between 1.9 and 2.8, and so on and so forth. So look at the shape of this right here. We can get a sense of the distribution of our data. Most of the things are sort of clustered around 3 here, right? And we don't have much of a long tail because the max is 10. So this gives you a really quick snapshot of your data quickly and easily. It's a great set of tools. There are a few other ones that you might like there as well. And so use it to check to make sure that you can join. How am I doing on time? Awesome. Thank you. Okay, so here are a few ways we've seen people have trouble with this. And again, I want to stress that these are very competent engineering teams who are doing amazing work, and this is something that's like really hard to get right. One of them didn't have joinable IDs, so they were tracking transactions on one hand, and they had a transaction ID, and they were tracking clicks around on their website, and they had a user ID, and they didn't overlap. There was no way to join those two tables together. So they had really rich data, but we couldn't do very much interesting stuff with it until they added a key that we could join on to both sets, which was, again, took maybe an hour to fix and deploy and test, but like really critical that you check that this is there. Another one, which is a more interesting case, is that they didn't have unique IDs at all. Each user in their system didn't have a unique ID, and that's because this wasn't a tech company, and they're getting their data from a distributed set of data sources that were sort of federated, but they didn't have any direct authority over them. And this is actually a more common scenario than you might think outside the tech worlds, and we're still sort of trying to find the best way to handle this situation, because they can't force any of their data sources to assign a user ID, making sure it's unique across all the data sources would be very challenging. So it's possible, but it's expensive, both politically and time-wise. And so what we're looking into doing instead is doing some sort of matching on name, last name, and birth date, and sort of manually cleaning up the ones that don't cleanly match. So this is another unique situation. If you're thinking to yourself, like, how hard could this possibly be? You just make a new table in your Mongo or whatever. Like, there are actually legit reasons why this is hard to do. So make sure that your data set is connectable. So today we've talked about, is your data set complete? Is it correct? And is it connectable? And hopefully you have some place to start in digging into your own data today. Here's a pro tip, especially if you're thinking to yourself like, my boss is not going to go for this, but it seems important. Write down everything you do. And actually do that anyway, even if you don't have a boss or if you are the boss or whatever. Write down all the things you check and write down all the things you find and you fixed. And even if you check and your data set and your logging seems great and fine and perfect, you still have a record of what you're confident in, which is important. And you can pass that on later to someone who's doing data science work. So what's next? What's next for this? Right now, there doesn't seem to be a common consensus around best practices in this in the industry. I'd love to see that come about. I'd also love to see us learn from unit testing in software development to find a way of, like, before or as you're writing a system, figure out what sorts of information you expect to come out of it and have an automated check run that can alert you if that doesn't happen. I met some folks at Strata who were talking about doing that, and so I'm really curious to see where that goes. So thank you very much. I appreciate you coming to this talk.